of wave function. So first, what is wave function? So wave function is expressed by the symbol psi. The relation lambda equals to h by v from de Broglie concept of any wave particle between momentum and the wavelength lambda, which has been experimentally verified for both photon and particles like electrons, suggests that it is possible to use a concentrated group of waves or a wave packet to describe the localized particles and the photon of radiation. The associated de Broglie wave function, which is depend on the two factor, one is 3D position and another time parameter is time, is a function of a space variable. That means here r equals to is a function of xyz, that means xi cap, yj cap and zk cap. So basically r is a function of xyz, so basically r is a function of xyz, okay, xyz, and also time, that is t, and it can give nearly completely information about the state of a physical system at a particular time in accordance with the rules of quantum mechanics. It is also known as a state function. So basically we know that this psi is basically in a 3D there are two independent parameter rt. For one dimensional there are only one parameter xt, and if we denote in a 2D form then only xy and the time parameter t. Okay, so this is the basic definition of psi. Next we talk about the physical significance of this wave function psi. Okay, so next we discuss about physical significance of psi and also mod of psi square. So first relation is that it can interfere with itself. This property explains the phenomena of electron diffraction. Number two is that it is large in magnitude, where the particle, that is electron or photon, is likely to be located, and small elsewhere. And in other words, the probability of experimentally finding the particle described by the wave function psi at the point xyz and time t is proportional to always mod of psi square there at time t. Okay, so psi square is basically psi square is the square of the amplitude of the wave function psi at t, gives the probability density of finding the physical system, that is particle or photon, at a particular place at a given time t. So if we write the complex quantity like psi is equals to a plus ib, okay, if we write in this form, and therefore psi star, always this is the imaginary part get negative, okay, and the probability density psi square is always equals to a square plus b square. That means this psi square is also denoted by this term psi into psi star. And number 3 is very important. Point number 3 is that the wave function describes the behavior of a single particle or photon and not the statistical distribution of the number of such quanta. Now we discuss about condition for wave function to be well behaved, that is the condition for a well behaved wave function. Okay, now we discuss about condition for the well behaved psi. Okay, so now first condition, psi must be finite for all values of x, y and z. Note down. Number 2, psi must be single valued, that is for each set of values x, y, z, psi must have be only one values. Number 3, psi must be continuous in all region except in those region where the potential energy is equal to infinity. Number 4 point, psi must be vanished at infinity, that is psi equals to 0 at x tends to plus minus infinity, also y tends to plus minus infinity, also z tends to plus minus infinity. In other words, we can say that minus infinity to plus infinity, the psi star psi, this is psi star psi dx is less than infinity. And number 5th point is very important. Number 5, the particle derivative of psi, that is del psi by del x, x axis, del psi by del y in the y axis, and next del psi by del z in the z axis must also be finite, single valued and continuous at all points except at points where the potential Vx equal to infinity. Okay, so next our discussion is that to derive the time independent Schrodinger wave equation. So for time dependent Schrodinger wave equation, first off we consider that a plane wave moving in the x direction is represented in the exponential form. So first we consider a plane wave. Okay, first we consider a plane wave moving in the x direction is represented in the exponential form, that is expressed by this equation: y is equals to a to the power I omega t minus kx, where omega equal to frequency, k is the wave vector, x is the direction, and t is the time. Okay, where k equal to 2 pi by lambda, omega equal to 2 pi nu. So now we know that energy E equals to h nu. Okay, so therefore nu equals to E by h. So now omega t, what is the value of omega? Omega equal to 2 pi nu. Okay, that is t. So now in 2 pi, and in the nu we put here E by h, this is t. So now this is E into t divided by h by 2 pi. So this h by 2 pi is another parameter which is known as, yes, this is known as h cut. So basically we see that omega t is also expressed by this term et by h cut. So now we discuss about kx. What is a k? So k is basically 2 pi by lambda into x. So now this is 2 pi by lambda. In the lambda we put h by px. So here px into x from de Broglie relationship, lambda is equals to h by p. We already know from the de Broglie. So now this is px into x, h by 2 pi, that is also h cut. So this is the term kx. Okay, where h cut is equals to h by 2 pi. Okay, this is one parameter. So now this is our equation 1. So this is our equation 1. So now this is our equation 1. Let's say this is our equation 1. So now we substituting this value in this equation 1 and express plane wave moving in the x direction. So what are the equation? The equation is y equals to a e to the power I. Instead of omega we put here this value, and instead of k we put here this value. Okay, so now the final expression is a e to the power I by h cut e into t minus x into px. So this is for one dimensional case. That's why here x is coming and px is coming. So now this is the expression of psi xt. Okay, now if we just, so this is the uniform plane wave expression, and we know that electron in a beam traveling in the x direction with constant momentum px and energy E is controlled by the pilot waves with a wave function psi, which plays the same role for electron and other particle as the displacement y of the sound waves of electric field vector E for the electromagnetic wave. Thus this psi of xt as a function of x and t denotes the amplitude of the matter waves at a point x at a time t, and given the similar equation, so we also say that this y also represented by this psi of xt, and this is expressed by this expression ei by h cut minus sign, because we just write down first ex px and then e into time. Okay, so this is our expression. Okay, clear? So this is our, for a wave moving along the positive x direction and represent a wave moving along the negative x direction by this equation. So now this is the expression of the moving along the negative x direction, limiting negative x direction of the x-axis by this equation. So now we calculate some parameters from this equation. So in the last equation we see that psi xt is equals to a e to the power minus I by h cut x px minus et. Okay, this is x for one dimensional. So now if we take a derivative del psi by del t, then it is represented by this equation. This is E and this is again psi, and therefore this is E psi equals to minus h cut by I del psi by del t. Okay, now we take this equation, derivative of this equation with respect to x. So del psi by del x. So del psi by del x is basically I by h cut px okay, just one denote here. We denote in the positive x direction, so that's why here plus here, and that is minus. And for positive x direction, we just consider in the positive x direction, and if negative x direction, then this is minus and representation. Okay, so I by h cut px into psi of xt again. Okay, so that is again the second derivative. So this is the expression, the final mathematical expression is this. So now from here, if we get the value px square psi, then we get h cut square del 2 psi by del x2. So now we discuss about particle subject to force. So we know that for a non-relativistic case, a particle of mass m moving with the velocity v and whose wave function equal to psi, therefore the total energy is equals to summation of kinetic energy, that is half mv square, plus potential energy. Okay, so now we express this equation, this m square v square, and there is m is another parameter, then therefore this expression is also this x direction by 2m. We consider the psi is along the x-axis, so that's why here we denote in the momentum in the x coordinate. So multiplying both sides by psi, therefore we getting E psi equals to px square psi plus v psi. Okay, so now substituting the value of E psi and px square psi. So what is the E psi? E psi means I h cut del psi by del t, then is equals to what is the value of px square psi? Minus h cut square by twice m, because you already calculate these values, plus v psi. This is the one-dimensional Schrodinger equation. Okay, so this is the one-dimensional time dependent, because here time is included. Wave equation for a wave associated with a moving particle in a potential field capital V. So this is a time parameter, this is wave function psi, this is the x coordinate, this is m means the mass of the particle, this is h cut means the reduced Planck constant. So this is the expression of the time independence Schrodinger equation. Now if we express in a 3D equation, then just we put here I h cut this and minus h cut square by twice m. For 3D there is xyz present, so therefore here we introduce the new parameter, the grad square psi, okay, plus v of psi, and here in this bracket we denote, in this bracket this is denote, I can't mention the xt, okay, this is basically xt, so here we mention rt. Why rt? Because in a 3D there is a resultant vector r, which is the position vector of the particle and which is dependent on the three parameter x, y and z respectively. Now we discuss about what is a free particle. Student, please note it thoroughly. For a free particle, what is a free particle? The free particle means there is no potential, that is, a particle is said to be free when there is no force acting on it. In such a case, the potential energy V of the particle equal to 0. So now what is the equation? So here potential equal to 0. So now what is a free particle equation? I h cut del psi by del t is equals to minus h cut square by twice m, okay, del 2 psi by del x2. So this is the Schrodinger equation, time dependent equation for a free particle. So this is very easy. Now what is in a 3D very easy. So for a 3D, they just cancel out this potential expression. Okay, so this is the Schrodinger equation for a time dependent